Hello, my name is Tejas Kulkarni. I'm in 5th grade. I'm doing this course with my dad, and I'm hoping to learn a few new things about physics. And this is a video we made about Lab 4, spring with the mass attached to it. As we analyze the system, there are two forces acting: Fg, the gravitational force, and Fs, the spring force. Well, Fg is equal to minus mg, and Fs is equal to minus kx. So K is the spring constant and X is the displacement of the relaxed line. So F net is these two forces added together. And T is equal to 2 pi multiplied by the square root of m over k. And we get K is equal to 2 pi r squared divided by t squared multiplied by the mass. From the calculations, T is equal to 1.524 and K is equal to 6.83, or T is equal to 1.614 and K is equal to 6.09. We can now calculate Fg and Fs in our models and apply Newton's second law. This is essential for measuring the acceleration in the period delta t and adding it to the velocity to calculate the new velocity. Now, let us see how the energy principles apply here. If we consider the complete system to include Earth, then the total energy change in the system should be zero. Delta E is equal to delta Uj plus delta Uk plus delta Us, and that equals 0. And so Uj is the gravitational energy. Uk is the energy, that's the formula to calculate Uk. Us is the spring potential energy, and that's the formula to calculate Us. Where X is the displacement of the spring from the relaxed line, and K is the spring constant. Since the total energy change is 0, we expect that the total of changes, all energy remains 0. This means that as one of the energy increases, it is compensated by the decrease in the other types of energy. This can be clearly seen in our energy graphs in the Python program. First, I will show you the energy changes in the tracker file, followed by the comparison with the Python file. Okay, so this is the video and we ran it in tracker. The graph is on the right hand side, which we will show you in a bigger form after the video is finished. Okay, this is the graph we acquired from tracker. Okay, and so the ball's mass is there, and this is the ball's position. So this is Ks is equal to 6.83, and L0 is equal to 0.123. S is equal to the magnitude of L minus L0. And K is calculated by this formula. Ug is calculated by this formula, and Us is calculated by this formula. Okay, so the F gravitational force is this formula. F spring is this calculated by this formula. F net is those two forces added together. And this is how you calculate the ball's velocity, final velocity. K is calculated by this formula, and Uj is calculated by this formula. And this is the graph plot that we use. Now we're going to run the module. Okay. The graph is on the right hand side. And the black arrow is the F net, so that's Fg plus Fs. Okay. So now we're gonna run the module with a different, except the module is gonna be the same, except the graph is gonna be slightly different. And I think we may have played the wrong video. So this is the one with the different graph. So everything is the same in the video. So the F net is the black arrow calculated by FG plus FF. Thank you.